I'm Richard Plaugher. I am sales manager with GL Sciences, and I do understand that I am standing in the way of happy hour. So we'll make this fast. This all comes from a discussion I had with my finance guy the other night, and we were moving things around. He said, Richard, what you got to do is you got to understand that you got to look at two things when you move things around. That's a thief in the day and a thief in the night. I said, well, what's a thief in the day? He said, well, if you're moving financial things around, that's the taxes and the cost. If you're the thief in the night is the inflation. So I got to thinking about this, and I said, well, that has something to do with the silica purity of GL Sciences. I know that was a long stretch, but first thing, the first thing they do is look at the shape of the silica particle itself. They do an electron microscope slide. They look at this. They look at the shape of this as compared to some of the others. You want to just essentially a round, smooth particle. The second thing they look at is the selectivity. They do this with every lot. They look at the selectivity to make sure everything goes to baseline and to make sure that that they can get the consistency out of every column. And the next thing they look at is the durability of the inertial. They run 500 volumes of 0.1% TFA through each column to make sure that these columns are durable, that they're consistent. Now, I also asked, well, what's the thief in the night, which is which is really two things. The first thing is the residual silanols, because these things are obviously charged, so you want your column to do what you think it's going to do, what you expect it to do, and not what something else will hang up compounds on the column. So from this analysis, you can see that once we do the binding and once we do the end capping, all the silanols are gone. The next thief in the night is metal contamination. They'll run an NMR on every on every batch to make sure that the metals are not contaminating the silica. This, of course, is charged, so again, you want your particle to do what you think it's going to do. If it's a C18, it's supposed to act like a C18. If it's a C8, it's supposed to act like a C8, and you don't want any thieves in the night hanging up your compounds. So this is just a summary of the kinds of quality control they do. The scanning electron microscopy. We look for trace amounts of metals. We do a particle size and surface area. They also do a pore diameter and pore volume size. But the main thing is we do NMR on every one of these lots so that we can look at the silanols and the metals. This is a new column we have out called the ODS4. They've really done this to increase the speed in the analytical lab and to increase the sensitivity. Thank you.